Okay, Papa 2 students, today you're going to learn about some quadratic applications. So please make sure you have the document downloaded or printed out. You will need a calculator, so have your graphing calculator ready or your software on your computer for this. So first, I need you to pause the video and just try the do not on your own. Go ahead and do that now. Okay, hopefully you tried the do not on your own and realize that the width of the garden is on the x-axis, the area of the garden is on the y-axis, so that was number 1. Here, the reasonable area for this garden goes from 0 to 25. 0 has a parenthesis because the area cannot be 0 if you have a garden. 25 has a bracket because the area could be 25. And the area represents the range of this function. Number 3, the width would be from 0 to 10. Both of them non-inclusive because you can't have a rectangle with a width of 0 or a width of 10 because then you wouldn't have a rectangle here. And the widths are the domain. Then if you answer the rest of these, if the width is 2 feet, the area is 16 feet squared. Make sure you put units. If the area is 21 feet squared, then the width could have been 3 feet or 7 feet. Make sure you put the units. And finally, the maximum area was the 25 feet squared because that was the max up here. And the dimensions I give you, the max area, were 5 feet by 5 feet. So that was just a little do not to get you started. Now we're going to actually do an example of what you're expected to do for this class. So number 1, a rancher is constructing 2 rectangular corrals from 100 yards of fencing. The corrals consist of a large rectangle divided by a fence in the center as shown below. So here's the picture, it's already been drawn for you. What are the dimensions of the large rectangle if the rancher wants to maximize the area? So I already have here like step by step on what we should do. So the picture's already been drawn. You have the large rectangle that measures x by y. And then it has a fence in the middle because you're dividing it into 2 rectangular corrals. So step 1, I need you to write an equation expressing y in terms of x. So based on this information, this corral for the fencing, you would have to add all the sides here, including the fence here. So if I add all of the sides, y plus x plus the fence in the middle, that gives me a 3y plus 2x. That represents the fencing that the rancher needs, and that needs to be 100 because that's how much fencing he has. So now I'm just going to write for y. I'm going to solve for y, so I can solve for y in terms of x. So my y here is going to be 100 minus 2x all over 3. And I can just leave it like that because I can put that in the calculator as is. Number 2 says, write an equation for the area of the large rectangle in terms of x. So the area of any rectangle is going to be the length times the width. So I'm going to multiply x times y for my area. Area equals x times y, but instead of putting y, I'm going to put what y was equal to in terms of x. So I'm going to put x times 100 minus 2x over 3. So that's step 2. I have written my area equation in terms of x. And now step 3 says graph your area function to find the maximum. So for that, we are going to need a calculator now, so get it ready. We're going to have to graph this function, find a good window, and find the max. So on your graphing calculator, so on our graphing calculators, we're going to go to the graph and graph our area equation, which was x times parentheses. And then I like to do a controlled divide so I can have a numerator and a denominator. My numerator is 100 minus 2x, and the denominator is 3. Then just press enter, and it's going to graph our area function. And now you need to find a good window to make this work. So there's a couple of options. You can always just go to menu and then number 4, window zoom, and try to zoom out. That's what I start with first. Press enter, press enter. Okay, at this point, let me hit escape. So I like my X window because I can see the parabola going up and then coming back down in the X direction, but my Y window is not big enough. So over here in my Y window, I can double click on that and maybe change that to, okay, let's say 100. Okay, press enter. That's still not tall enough for the Y value, so maybe do 500. Okay, that's pretty decent. So there we go. I found a good window, and that's what you need to do. Make sure you practice finding a good window. Remember, you go to menu and then you go to window zoom and then just try playing with that. So now that I have a good window, I'm going to do what it says, find the maximum. So for that, you go to menu, analyze graph, maximum. Take the cursor to the left of the vertex, take the cursor to the right of the vertex, and it's going to give you your maximum here. So now I have my maximum. So I'm going to write that down and on my paper. Okay, so I'm going to answer, I guess, step 4, answer the question. I'm going to put it over here where there's more room. So the question was, what are the dimensions of the large rectangle if we wanted to maximize the area? So remember, this was our maximum here. So that means that, for starters, I know that it didn't ask this, but the max area for the large rectangle would be the 416.667 feet, or actually it's yards squared. And I do need you to round to 3 decimal places. So let me put it over here, round to 3 decimals if needed. So the max area was 416.667 yards squared. Now the actual question was, what are the dimensions? So the dimensions would be, remember, X was 25. That was what gave you the maximum. So 25 yards for my X. And now I need the Y. So for the Y, we just need to go to my Y equation and plug in. So 100 minus 2 times X. And remember, X was 25 divided by 3. If you type that into your calculator and simplify, it gives you 16.667. So the dimensions of this rectangle that give you the maximum area are 25 yards by 16.667 yards. So that would be the final answer. And that's how you would do number 1 using your calculator. And let's try the last example, very similar, number 2. Okay, number 2, a rectangular field is 300 yards by 500 yards. So here's the picture. A roadway of width X yards is being built inside of the field. So this thing right here is the roadway, the little border. The problem concerns the region inside the roadway. So we're talking about this smaller rectangle inside. That's what this problem is about. What is the widest the roadway can be and still leave 100,000 square yards in the region inside? And then what is the reasonable domain for the situation? So step 1, write an equation of the area of the inside region in terms of X. So we need to figure out what would be the area of this rectangle, the inside rectangle. So the area of this inside rectangle, we first need to take the dimensions. So we need like the length and the width of our little inside rectangle. So the length here is going to be the original 500 minus, we need to subtract 2x because that border goes all around. So there's an x here and there's an x right there. So that's the length of our small rectangle, which is the area of, which is going to be the region inside. And then the width of this small rectangle is going to be the 300 minus 2x as well because of the border. So if you multiply that length times that width, that's going to give you the area of the inside region, which is what this question is about. So that's number 1. Number 2, we have to graph your area equation, and we're going to be graphing also the y equals to 100,000 because the question wanted to know when will that area be the 100,000 square yards. So on your calculators, what I like to do is doc B just to clear the calculator. Doc B. We'll go back to the graph, and I'm going to be doing typing in the area equation. So 500 minus 2x times 300 minus 2x, enter. Okay. Make sure you find a good window here, and remember there's different options. I always go to menu, window zoom, and then zoom out. Press enter, press enter, press enter until we see something. Okay, there I see something, but that's not enough. Okay, there we go. Press enter one more time. So I see in the X direction, press escape. So in the X direction is good to go because I can see the parabola going up and then coming back down. But in the Y direction, it's not, we need to zoom out in the Y direction so we can change the Y scale. And for the Y scale, remember that's the area. If you go back and look at your problem here, it gives you like a big area of 100,000. So that means that for my Y scale, it's gonna have to be pretty big. So like maybe let's put at least 200,000. 200,000. And then I'll do the same thing for the negative. I know the area can be negative, but I just like my window so I can see it. Negative 200,000. Nope, that's not a good window. Oh, I changed that. I don't know. Undo. Control undo. There we are. Okay, so that was a pretty good window there. I don't know, I just zoomed out. Just play with the window so you can find a good window. That's pretty decent. That looks good. So that I've graphed my area equation, but I forgot to graph the 100,000. So hit tab, and then I need to find the dimensions that would give me an area of 100,000. So I need to graph 100,000 for the F2. There you go. So there it is. And that's what you have in your paper. So I need to find the intersections of, find the intersection of the area. When will the area be the 100,000? So I'm going to find those intersections. Menu, analyze, graph of intersection. And let me find this first intersection over here. Okay, so if x is 34.1688, the area is 100,000. And we can find this one over here, although I'm not going to need that one. I'll tell you why in a minute. This one is not going to be, what happened? This other intersection over here is not going to be a reasonable intersection. We'll discuss that in a minute. Well, here, we can just talk about it now. So the other intersection would be that x would have to be 365.831 in order for the area to be 100,000. Well, x can't be 365 because remember our picture over here, you can't subtract 365 if the width of this is only 300. We can't do 300 minus 2 times 365. So that other intersection here is going to be extraneous and we don't need it. So we're just going to ignore it we're just going to ignore that. So now I have those intersections, which is what step 2 says. And I need to find the x-intercepts because that's going to give me a reasonable domain over here. So I need to find this one x-intercept here. We can find both as well. So the way you find an intercept is menu, analyze graph, 0. That's the x-intercept. And you want to find the zeros of this parabola. So press on the parabola, the lower bound, press on the left of the 0, and then press on the right of the 0. So this is one of my zeros. And there is another 0 here, which is going to be extraneous, but let's just find it so we can see why. Menu, analyze graph, 0. And again, you need to click on the graph so that you can select the graph you're finding the zeros for, and left and right. So there it is. This other 0 is also extraneous because, like I just said, x can't be 250 because you can't subtract. The roadway can't be 250 yards wide if your rectangle over here only measures like 500 by 300. So you can't do 300 minus 2 times 250. It doesn't make sense. So now we have all that information, and we are going to write it down on our paper. So let's do that. On our paper, the graph is already here made for you. And we need to, the last thing I forgot. All right, another thing that you definitely need to know how to do with your calculators is you need to know how to round to 3 decimal places on the calculator, because the whole note should say to round to 3 decimal places. So like for example, here my first intersection, 34.16888. Okay, so that's too many decimals. You need to be able to round those or show me only 3 decimal places. So here's one thing you can do. You take your cursor and you go to that number that you want to see 3 decimals or more decimals. So make sure the little hand is open like that. If you press the minus sign or the plus sign, it's going to give you more decimals. So here, take the cursor. So like, let's say I press the plus sign, it gives you more decimals. Or let's say I press the minus sign, it should be giving me less decimals. There we go, minus sign. Press the minus sign, there we go. So that gives me only exactly 3 decimals. So I can do that over here too, just for practice. Make sure the little hand is like, there we go, it needs to be open. And you can press the plus sign, and it's gonna give you a lot more decimals if you want more. Or you can press the minus sign, and it's gonna give you less decimals. The little hand needs to be open for it to work. Minus sign to give you less decimals. Okay, just playing with it. All right, so make sure you know how to do that on your calculators. And all right, let's actually answer the question. Graph your equation, we've done it. Find the x-intercepts, we've done it. All right, so now let's answer the question. Okay, what was the question? What is the widest the roadway can be and still have an area of 100,000? So we did find that intersection there. So if x equals 34.169 yards, the area would be 100,000. The area is 100,000 yards squared. So that's my first answer for the first question. Make sure you put units. And then the next one has to do with the reasonable domain of the situation. So for my reasonable domain, or just reasonable domain, or we're just going to call it the domain for the situation. Okay, the domain for the situation is only going to be, and that's going to be our x. Remember, x is the width of the roadway. Okay, so x can be, I guess, from 0, because you can't have a negative width. So x could be from 0 up until, so based on the graph and your parabola, like you can't just put x to be all the way to positive infinity. It has to stop at this first x-intercept. It has to stop at 150. And I'm going to put parentheses around it, because the roadway can't have a width of 0, because then there wouldn't be a roadway. And then the roadway can't have an actual width of 150, because if you look at your equation, the one that says 300 minus 2 times x, if you do 300 minus 2 times 150, that's going to give you, again, 0, a width of 0. So that doesn't happen. It's not possible. So I'm going to put parentheses. And that has to be the reasonable, that's it for your domain, because like I told you on the graph, x can't be more than 150. Like all these other ones over here are not reasonable, because it doesn't make sense to subtract like 300 minus 2 times anything bigger than the 150. So then if you look at my answer key, it explains why x has to be between 0 and 150, not including the 0 and not including the 150. So now you just need to practice with your calculator and answer the questions and do your work.